All right, we've got our tutoring center problem again. So we've got departments, we have the number of tutors we can hire. We're asked to apportion these based on Huntington-Hill's method now. I'm not going to spend a lot of time on the first two steps. They're the same as what we've been doing. So I'm really hopeful that by now you've gotten the groove. Okay, we find that standard divisor, which is the total population, or in this case, total enrollments, divided by the number of representatives, 22 tutors in this case. All right, so that an original standard divisor is going to be 35.4545. All right, each of our quotas is the state's population divided by the standard divisor. All right, in this case, it's the department's enrollment divided by the divisor. So 380 divided by 35.4545 is going to be 10.718. I'm going to go through and fill in these values. Okay, again, hopefully you're feeling good about these first two steps as they are the same in every single one of our methods. All right, the lower quota was the cutoff. And really, you don't have to write in this column because it's not actually judging anything. It's just helping us get to our geometric mean. So the geometric mean is the square root of 10 times 11, square root of 6 times 7, square root of 2 times 3, square root of 1 times 2. It's the lower quota and then one above it, 10 and 11, 6 and 7, 2 and 3, 1 and 2. Inside a square root, it's these products, okay? So we actually want these numbers because we have to compare the geometric mean to the quota. We have to look at them side by side. So I'm writing out what they are before I put it in the calculator, but really you're putting it in the calculator and writing that value here. So the square root of 10 times 11 is 10.488. Rounded to 3 is fine. 6.481, 2.449, and 1.414. Now, the way we tell the allocation is we compare these two numbers. If the quota is bigger, we round it up. If the quota is smaller, we round it down. So what's bigger here, 10.7 or 10.4? In fact, I shouldn't say what's bigger. I mean, I can, it's the same question, but what I actually encourage you to ask yourself is the quota bigger? Is the quota smaller? Don't just look for the bigger number, ask, is the quota bigger? 10.7, is it bigger or smaller? It's bigger. Since it's bigger, it gets rounded up. 10.7 is bigger, so that gets rounded up to 11. All right, 6.7, is it bigger or smaller? 6.7 is bigger than 6.4, so that gets rounded up to 7. 2.9, is it bigger or is it smaller? The quota is bigger than 2.4, so it gets rounded up to 3. All right, 1.5. Is it bigger or is it smaller? 1.5 is bigger than 1.4, so the quota gets rounded up. So every single one of these got rounded up this time. 11 plus 7, 18, 19, 20, 21, 22, 23. That is too many, okay? It's too large, it's too high. And what do we do when the number of allocation is too high? We increase the divisor. I know a lot of students, they say, oh, it's too big, I want to decrease. Well, yeah, I want to decrease the number of tutors, but to do that, you do the opposite to the divisor. So I need to increase the divisor. 23 is too big, I need to increase the divisor. So I'm going to pick a number bigger than 35.45. Maybe I go to 36, but based on my notes, because I've tried this out and done all of the math, I don't think 36 was high enough. You could try it. Maybe it was. Maybe I jumped to 37 for no reason, but I wrote 37. So we're going to go with 37 on our modified divisor. Okay, just because that's what I did, and I have all the divisions already there for it. Okay, but again, you could have increased to 36. In fact, if I was doing this for the first time, I would have increased to 36 next, and I would have tried it first. And then if it didn't work, I would have gone up to 37, okay? But we're gonna jump straight to 37 this time. We find the quotas, 380 divided by 37. 10.270. 240 divided by 37. 6.486. 2.838. 1.486. All right, the lower quotas are just the cutoff values without the decimals, just the lower part. The geometric means are those lower quotas times one above it in a square root. Square root of 10 times 11. Square root of 6 times 7. Square root of 2 times 3. Square root of 1 times 2. Again, that's the whole purpose of the lower quota, is so we see what the lower number in our geometric mean is. You'll notice that these are the same geometric means, so you don't need to re-put them in your calculator. You can just mark in the geometric means for each of these again. Those just came straight from the calculator. And if you haven't already done it, I want you to try to fill in the initials on your own. Remember, the question on the table is the quota bigger? If it is, round it up. Is the quota smaller? If it is, round it down. Whichever way the quota is compared to this other number, that's how we round. So pause, try to fill in your initial allocation, see if you get the same thing as me. All right. 10.2, is it bigger? No, it's smaller. All right. My quota is smaller, therefore we round down, we keep it at a 10. 6.4, that's the same. 6.48, that's the same. This is why we need more than just 2 decimals, all right? We would be tied here. So my quota is bigger because of that 6, therefore we round it up to a 7. All right, we round up because it was bigger. Is it bigger or smaller? 2.8 is bigger than 2.4, so we round up to 3. 1.4, 1.4 as well, but we continue on to the next place value. 1.48 is bigger, so we round it up to 2. And 10, 17, 18, 19, 20, 21, 22 is our number. Was that our magic number? Was that the correct number of tutors? It was indeed. So we are now done. This is actually our final allocation because it's the proper amount here.